Hello, class receiving students and teachers. Thank you. You may be seated. Now we are still on the same strand and substrand. Same outcome, which is 8.3.1 and unit title. Now to recap, we have a statement that says describe how particles move in each of the states of matter. Now I would like Michelle, if you can describe the three states of matter for us.
The first state of matter is solid, and the particles in there are held in a fixed position because the attraction is very strong. And in liquids, the attraction is a bit weak, not very strong, so therefore they can collide, change positions, and move around. The particles can move around. And in gases, they have a lot of space because the attraction is very weak, and so the particles can move around quite rapidly.
Very good, thank you. And I hope receiving students, you have also tried to give that same type of answer to your teachers. Now our topic for this lesson is everything matters. Everything matters. Now in the previous lesson, we also learned about what matter is. What matter is. If I can have Aquila, if you can give us the answer to that question.
Anything that has mass and take up space.
Very good, thank you. Anything that has mass and takes up space. Good. Now, matter or substances naturally exist in one state. There is one substance or matter that exists or that can be found in the whole three states: solid, liquid, and gas. You can tell me what that substance is. Are receiving students? Let your teacher know too. Thank you. Let's have Winnie, please.
Particles.
Good, thank you. Particles. Good try. Anybody else? Okay, let's have Ella.
Liquid.
Liquid or water. Okay, water is the only matter that can be found in all three states, while the others, they can be found in one state. Now we have solid that can become liquid, and from liquid it can become gas, and from gas back to liquid and back to solid. Now from solid to liquid, what is the process called when it's changed from solid to liquid? Okay, let's say Juanita.
Melting.
Melting, good, thank you. From liquid to gas, let's say one of you over there, that group.
Evaporation.
Evaporating or evaporation. Rachel, from gas to liquid.
Condensation.
Condensation, thank you. From liquid to solid, let's have you.
Freezing. Freezing.
Freezing, good, thank you. Now you have it already on the slide, so that should help you to know each of those different processes that takes for water to change from one state to another. Now we are going to be doing an experiment. And I'd like you to take note, receiving students as well as the class. Take note of the safety rules. Now, generally, we have the first rule that says take extra care when carrying out the experiment. It is very, very important that you take extra care in whatever you are going to be doing in these experiments, as well as the other experiments that you will be carrying out all throughout this year. 2, you are to avoid standing too close to the burning burner. You will be handling a burner, and it's a bit dangerous for you to stand very close to it. Also, do not play around during the experiment. There is no hide and seek. You are supposed to be concentrating on what activity you will be doing. Now, before you do the experiment, make sure your tables are cleared. Everything you have should be put away, and you only have the apparatus that you will need for the experiment. Now, before we can go to the experiment, I'd like you to just look this way, so I can just show you some things that you have to know before you carry out the experiment. Now, especially with the burner, when you light the burner, okay, you light it, you do your experiment, and after the experiment, when you want to put it out, you are not to blow the flame out, okay? You use the lid, put it over the flame, and it goes out. Don't blow it out. Now, also, you will be using a spring balance. Now, on the spring balance, there are divisions, and we have the numbers. Once you get your spring balance, you will check to see that. You will have the numbers from 0 to 100, 200, all the way down to 1,000 grams. Now, between 0 and 100 and 100 to 200, we have divisions there. Each of these divisions they value 20 grams. So take note of that as you are carrying out your experiment, especially in measuring. Okay, thank you. If I can have the runners, before we go to that, please, if I can have you to move to the groups that I ask you to go to. Can we move quietly, please? Group 4, 5 with group 1, 6 with group 2, 7 with group 3, 8 with group 4. 9, you split up and join the others. Now, we will have group 1, 2, you will move down there so we have space. Group 2, if you can move down there. Group 2, 3, you remain. 2, move down there. Please move quickly. And group 4, if you can move further to that table over there. So we have space between where, because you are going to be in a big group, you have space for others to stand around. Okay, thank you. 8 is. Now we should have 4 big groups. I've already explained my reasons why we can't have you all to your own groups. Now our activity for this lesson, first thing we are to predict which of the state of matter of butter will be heavier when weighed. Now we are going to be working with butter. And you are going to predict which one, the butter in solid or butter in liquid, will be heavier. And what you are going to do, with the model class, you have your results table there, but with our students in the receiving schools and teachers, your results table will look like this. And when you make a prediction, that is what we are going to be doing right now, you are to state or tick which one of these two state of matter, solid or liquid, you think it's going to be heavier. This is talking about butter. When butter is in solid, is it going to be heavier than liquid, or liquid, when we change it to liquid, it becomes heavier than solid? So you are going to put a tick next to that, one of that, and you have to explain your reasons. If you say solid, then what's your reason for saying solid? If you say liquid, then what's your reason? So we are all going to do that, and I'd like the class to do that as well as the receiving students. Discuss together quickly, and you can do that. Now you think of butter solid and butter when it's melted. So which one do you think will be heavier? Okay, you have to discuss quickly and get the table filled. You have to do that right now. Quickly. What do you say? Eddie, what do you say? Think quickly. Okay, come up with what quickly and put a tick and then have your reason down. So what do you say? Michelle, you and your friends, what do you say? Okay, the girls are saying liquid. What about you, the boys? Okay, what's your reason? Then you have to put a tick. Liquid. Why do you say liquid? You have to have your reason written. Which one did you take, solid or liquid? Solid. What's your reason? You have to have a reason for saying solid. Why do you think solid butter is going to be heavier than liquid butter or melted butter? You can't just say solid. You must have a reason. Okay, come up with your reason quickly. What do you have? You haven't started yet. You have to get the prediction done before we do the experiment. Where? Butter in which state? In solid, you think it's going to be heavier than liquid, or when it's melted to liquid, it's heavier than solid. And when you say that, what's your reason? Okay, we should have finished with our predictions. I'll just say one group to tell us what their prediction is. Let's have group 3. Group 3, if you can tell us which state of matter you have put a tick, solid or liquid. Your predictions. Use the mic. Okay, group 3, they're going to give us our predictions, but you all should have your own predictions and your reasons for those predictions.
Our prediction is solid.
Solid. Now, what's your reason? Why do you say solid? What did you have? What did you put in your paper?
Because the particles in solid are packed together, and they are close together so they can weigh higher amount than the liquid, because when the solid is melted and becomes liquid, the particles loose apart from each other.
Okay, good, thank you. That's our group 3's predictions. I hope you others also have your own predictions, as well as the students in the receiving school. Now I want us to have a look at class and the receiving students. This is how you are going to set up your apparatus. I'd like you to look at it. So once you get your apparatus, you do what you just see instead of waiting around, wasting time. Now we have the retort stand. This is improvised one made from timber. You will have a spring balance. You hang the spring balance, and your glass jar, you should have already tied a piece of rope. If you haven't, you have it tied when we come to our lesson, and you hang it there. So that is how you should set your apparatus when you are doing your experiment. Thank you. If I can have the runners to come and get your materials. Just one retort and one of those trays. Those are my things. Now our instructions, please, I'd like you to follow as we go through. First one, you have to tie a piece of string. Okay, please, I'd like you to see the instruction and follow as it is. You tie a piece of string onto the glass jar with lid on. Everybody should be doing that right now. There was a piece of rope I put in. I thought I put a piece of rope in every one. You should be now with the second instruction. The spring balance. You haven't set up your apparatus like I did there. Come on, don't just sit down and wait for others to do that. Move your chairs away and you should be standing. You are to weigh the glass jar on the spring balance. Now, Michelle, if I can have you to tell me, why do you have to weigh the glass jar? Why will you weigh the glass jar? The what?
To find out how much it weighs.
To find out how much it weighs. Okay, good, thank you. Now Now the third thing is for you to record the reading of that glass jar in grams. Have it recorded. You read it. Take the reading of the weight of the glass jar. 180 grams. Okay, record it in your. There, you're supposed to be recording it there. You have a results table. You record the weight of your glass jar. Where's the results table? Okay. Now, good. Thank you. The reading of that glass jar should be already recorded in your results table. Receiving students, that's where it should be filled in. Now, the next is to place a tablespoonful of butter in the glass jar. I will come around and do that. Once I've done that, you are to weigh the glass jar with butter in it. Your glass jar. Sorry. Open it. You got the weight already. Get it out. Okay. Okay. Yep, weigh it. Did you get the... So, let's hope it goes down. So, hey. It's going down. Weigh the glass jar with the butter in and record the weight of those two together. Sorry, that's too much. Which one did you use? No, that one there. It has to be the same one. Now you should have all got the reading of that solid butter in the glass jar. And it should be recorded in the space provided there on your worksheets. Now, listen, you are to subtract the weight of the jar from the total weight of the solid butter and jar. Do that now. Subtract the weight of the jar from the total weight of the solid butter and jar. What is the weight of the solid butter? Move your hands quickly. So your solid butter, how much does it weigh?
200 grams.
No. Look at what answer do you have? 20 what? Grams. So that is the weight of the solid butter. The 200 is the weight of the glass jar and the solid butter together. See?
The solid only is 200 grams.
So when you to find it, you have to subtract. So what you have there, that is your answer. Let me see what you have. Okay. Not that, sorry, not that. Students in a receiving school, the weight of the solid butter, you get that after you have subtracted the weight of the glass jar from the total weight of the solid butter and jar together. So what you get as your answer once you subtract, that becomes the weight of your solid butter. Now we should have all finished with that. Now we are going to find the weight of that solid butter in liquid state. You are to put the solid butter from the jar into the Petri dish. Please all do that. There should be another spoon here. Oh, you got your water. Once you get your measurement, then you put it into the... What does it say? Into the... This is the Petri dish. The next step, you are to light the burner. I am going to do that. And once I've done that, you are to heat the Petri dish over the flames. Get it out. Oh, on top of this? And underneath. Goes underneath. Okay, your burner. Come with your burner. Okay, put it on the stand, the stand, and put it under the tripod. Next step, you are to pour the melted butter into the same jar. So once your butter is melted, you pour it back into the same jar, glass jar. Now, once it is melted, group 4 is already with the last one, pouring the melted butter into the same jar. I hope everybody is doing that. The melted butter, pour it back into the same jar. Now you are to follow the same steps as in the first activity on weights of solids. Weight of jar, you should have it already. The weight of jar you got from the beginning, that is the same weight. Now you weigh the jar together with the melted butter. And what you get as your answer is the weight of the melted butter. So what is it now? What's the weight of your melted butter with the jar? What is it now? 200. So from the glass jar. So the glass jar is no, the glass jar you got it already in the first activity.
180.
Okay, so you are going to, what are you going to do? What will you do to find your answer? Subtract. And what do you get as your answer? That's your answer for the melted butter. We have two groups already finished with their experiment. Now the next thing is for you to compare the weights of the solid and the liquid butter. Compare that to your prediction you have made. And as a group, you discuss and write a summary or come up with a summary and write it down. Everybody should be working on that now. Yeah, okay, you discuss with your friends, not by yourself. That's good discussion, but discuss with your friends. Huh? No space to sit down, so you can stand. do your discussion and somebody else gets it written.
Plus the jar is what? With the butter, solid butter in the jar. What was the weight?
Yes, what they come up with. Thank you. Thank you, Mike. So you're supposed to be discussing, okay? You compare the weights of the solid and the what butter, and then come up with your summary. Okay, thank you. If I can have one group to tell us of your summary, of your findings. One group. Okay, now we will have your summary. I will have someone from one of the groups in our next lesson, before we go with our next lesson, to give us of your findings of this experiment that you have done in this lesson. So I'd like us to go through our summary notes. Now, substance can change state when heat is applied, just like you have done in this lesson. Summary point 2, substance can also change state when heat is removed. In the case of that butter you have melted, once we have removed the heat and we leave it, once it cools down, it can turn back to butter again, solid. If you can have that written quickly before we go to the next summary point. We only have 2 summary points. There's no more than that. Our key phrase for this lesson, states of matter. Next lesson is on solids, still on matter. Solids, how can I tell? Now, materials for next lesson, receiving teachers, please take note of that, as well as the students in both receiving classes and the model class. Examples of materials made from wood, plastic, metal, ceramic, and glass. Things that are made from each of those materials. You also have to have a spring balance, nails, and small knives. And with that, thank you, class, the receiving students and teachers, for your participation.